Yeah. Good morning, my dear students. Today we are going to discuss about first order reactions. Okay, about first order reactions, rate constant, derivation, and half life, and what are the units and examples we are going to see today lesson. Okay, today concept. Okay, so here we are having first order reaction. First order reaction. First order reaction is a very important concept in a chemical kinetic. First order reaction. First order reaction. First order reaction. How to define first order reaction? First order reaction defined as the reactions in which rate of reaction directly proportional to directly proportional to concentration of reactants where power raised to 1 okay. So what mathematical expression we can write for this definition now? Let us say reactants are converting into products. For this one, what we are saying here, rate of reaction is directly proportional to concentration of R where power raised to 1, right? So what we can write, rate of reaction is equal to, now we can write K into concentration of R we can write. This is the first equation, okay. It is itself very important, ma. Okay. The reason is rate of reaction you will get by multiplying K with concentration of R. Okay. Rate of reaction we can get K into R you can get. Okay. So here from this one we can plot a graph. Okay. We can plot a graph from this one. Okay. That graph what we can draw, take here graph we can take ROR, rate of reaction, or rate, both are same only, okay. Or so we can write y is equal to mx, plot we can graph, we can take. On y axis you can take a rate of reaction, or you can take as a rate. On x axis you can take concentration of R. So it is directly proportional. Okay, it is what slope is what K, positive slope you will get. Okay, so from this one what we can write, rate of reaction means for this equation we can write rate of reaction decrease in the concentration of R. Why we are taking R? Since it is R is present, by dt, that is equal to, we can write K into R you can write, correct? So here we can write dr is equal to, we can write dr by R is equal to, you can write K dt you can write. Why? Because the R you are sending here and dt you are taking here, okay. So minus. So here from this one just if you multiply with minus now, what will happen, dr by R is equal to, you can write minus K dt you can write. Simple. Initially we was having minus dr by dt is equal to K into R we have written. Why? Because decrease in the concentration of R by concentration of reactant by dt is equal to K into R. So here we are just exchanging dt and R. So what will get, minus dr by R is equal to K dt. If you are multiplying with negative now you will get this one. Okay, so negative positive minus K dt. Now for this equation we are integrating both sides. So what we will write, integration of dr by R is equal to, you can write minus K into integration of dt. So if you remove the integration now, ln R is equal to, you will get minus Kt plus I you can get, plus I. So let us say it is a second equation. So for this equation we are applying some conditions. Let us say reactants are converting into products now at time 0 second. Initial concentration you can take it as a R naught. So this is what equation 3. Okay, equation 3. So conditions of 3 you are substituting in what 2? Conditions at 3, equation 3, substituting in 2. Then what will happen here? Okay, ln R naught is equal to R naught, you have to take what? R naught. Why? Because at time 0 we are taking. Okay, so ln R naught is equal to, we can write ln R naught is equal to, you can write minus k into 0 plus I we can write. So from this one what we can write? Ln R naught is equal to, you will get I, you will get, it is what? Equation 4. Now what you have to do? Equation 4 you have to substitute in 2, you have to substitute. Equation 4 you have to substitute in 2. Equation 4 you have to substitute in 2. So what will happen? Here you will get, okay, instead of I you have to substitute ln R naught. So you will get ln R is equal to, you will get minus kt plus ln R naught you will get. From this one what we can write? Okay, so yes, from this equation we can take a graph now. Okay, we can take a graph from this equation. Okay, so here see, we are having ln R is equal to, okay, ln R is equal to, we are having minus kt, ln R is equal to, we are having minus kt plus ln R naught is there, ln R naught. So what, which graph we can plot now? Y is equal to mx plus c. So on y-axis what we need to take here? On y-axis we have to take on y-axis you have to take ln R. Okay, on x-axis you have to take time, you have to take. So the slope you will get a negative slope, you will get, slope is negative, that is minus k. Okay, and what is the intersect here? Intersect is ln R naught is a y-intercept. Okay, this one, this graph is important. And next, so we will come to the derivation. So we got ln R is equal to minus kt plus ln R naught. So for this one, okay, minus kt is equal to what we can write? Ln R minus ln R naught you can write. For this equation you multiply with what? Minus. Okay, minus. Then what will happen? Kt is equal to, you will get ln R naught minus ln R you can get. Okay, this one. Now, okay, so this one what we can write? Ln A minus ln B is equal to, you can write ln A by B you can write. Okay, so we can write kt is equal to, you can write ln R naught by R you can write. So the ln you convert into log, then what will happen, dear students? 2.303 log you will get R naught by R you will get. So from this one, k is equal to, you can write 2.303 by t log R naught by R you will get. R naught by R. Okay, this is the formula for rate constant, first order rate constant formula, this one. So this also we can write like this. Okay, k is equal to, you can write 2.303 by t log initial concentration you can write A, final concentration means A minus x you can write. Okay, this is also same. From this one we can write, okay, what here R naught, R A means initial concentration of reactants. Now R means R, nothing but A minus X, both are same only, is equal to final concentration of reactant. Final concentration of reactants. Here T means what? Time taken. Time taken. Okay, and K is what? A first order rate constant. K is equal to first order, okay, rate constant. Okay, this one. Okay, so in this whole derivation, dear students, okay, few formulas are important. Those formulas are, okay, first thing is, okay, ROR is equal to rate of reaction is equal to K into R. This formula is important. And graph also from the ROR is equal to K into R. Graph important. And okay, this formula important. ln R is equal to minus KT plus ln R naught. From this one also they are asking graph and this formula is important for mathematical calculations. Okay, right. Now we are going to derive, okay, units of K. Units of first order K. K na rate constant. First order K. So what we can write? What is the common formula of units of K? Mole power 1 minus n, liter power n minus 1, and second inverse. So here we are writing first order. For first order we are writing. Then what we have to write? N is equal to 1 you have to substitute. So you will get mole power 1 minus 1 is 0. Okay. Something power 0 is 1, liter power 1 minus 1 is 0. So something power 0 is 1. So we will get units are what? Second inverse. K is what? K units of first order is the second inverse. And next examples of first order. First one. Okay, next examples of first order. Examples of first order. Again I am saying first order examples and all you have to remember. Why? Because by seeing one reaction we cannot say which order it is. Okay, few reactions they given in NCERT as well as in another competitive material, that one you have to remember. Okay, so order is actually experimental quantity, we will calculate by table problem. Okay, that one we will see later. So first one, all radioactive disintegrations are all radioactive disintegrations. All radioactive disintegrations are, okay, first order it will follow. Second one we are having, okay, dissociation of a peroxide. Hydrogen peroxide will dissociate to give H2O plus O2. Okay, this is also the best example for first order. And third one, okay, hydrolysis of ester. Hydrolysis of ester na, okay, ester hydrolysis CH3COO C2H5. This one plus H2O in the presence of acid. So here it is ethyl ethanoate. This is ethyl ethanoate. Ester name is ethyl ethanoate. Why? Because ethyl is there on ethanoate. Okay, 2 carbons, 1 and 2, 2 carbons. 2 carbon na ethanoate. Ethyl ethanoate. Hydrolysis na, you will get ethanoic acid. You will get ethanoic acid plus ethyl alcohol. You will get ethyl alcohol. You will get. And fourth one, okay, hydrolysis of sucrose C12H22O11. Okay, sucrose upon hydrolysis H2O, you will get glucose C6H12O6. Glucose you will get, and fructose C6H12O6. Glucose fructose formulas are same only, but both are functional isomer. One is ketone, one is what? Aldehyde. So glucose and fructose. Glucose and fructose are what? Functional isomers of each other. Why? Because we have studied in 11th standard functional isomers definition. Okay, the compounds which are having same molecular formula but different functional group. In glucose you will be having aldehyde group, in fructose you are having ketone. Okay, these two. And remember these two you can see in the example of pseudo first order reaction. Pseudo first order reaction. pseudo first order. Okay, pseudo first order also you can see. Why? Because okay, here how to define pseudo first order reaction? Okay, the molecules, okay, the reactions in which molecularity is 2. Here molecularity is how much more? 2 molecules are involving, but order is 1. So order we are taking with respect to ester. Okay, ester only we are taking. Okay, it is ester hydrolysis. Okay, so and next in this one, the sucrose upon hydrolysis will give glucose and fructose. No, this also follows pseudo first order. The reason is molecularity is 2, but order is only 1. Order we are taking with respect to sucrose only. Why like this? Here H2O is what? Excess. With excess reagent is there means excess reactant is there means from with respect to that, okay, order is how much ma? 0. Order is equal to 0. Here also with respect to excess reactant, with excess reactant, order will consider as a 0 will consider. Okay, so this one you keep a heading ma. Okay, ester hydrolysis, ester hydrolysis. Okay, order we are taking with respect to ester only will take. So for this one, rate of reaction, what we can write for this equation? Rate of reaction is equal to K into, okay, ester, okay, concentration power 1 and H2O concentration power 0. So finally it will follow the order is equal to ROR is equal to, we will get K into ester hydrolysis. So this one, the ester hydrolysis you can write finally ROR is equal to, you can write K into, okay, ester power ester concentration power 1, you can write. Okay, why? Because since water is in excess amount, okay, with respect to water is order is 0. So for this one, what we can write? Sucrose hydrolysis, you can write rate of reaction is equal to, you can write K into, okay, concentration of sucrose C12H22O11 power 1 and what? Concentration of water power 0. Why? Because water is excess. Hydrolysis of ester, hydrolysis of sucrose means what? We are hydrolyzing the sucrose means what? Water is excess amount. Okay, so we will write rate is equal to, okay, K into, okay, C12H22O11 power 1. Okay, the order is 1. Okay, like this. Okay, right. And next one we are going to see half life. We are going to see. Okay, half life of zero order, first order. So half life of first order. Half life of first order. So definition is same for half life. So how to define? The time taken to reduce. The time taken to reduce. The time taken to reduce its initial concentration. Its initial concentration into half. Initial concentration of reactant into half, called as what? Half life of first order. Okay, so while reactants are converting into products, okay, so at time 0 seconds it will be having initial concentration is R naught. At time is equal to T half na, it will be having what? In the initial concentration it will be having half. Okay, so this one, these are what? Conditions now. Initial concentration R naught means product is 0, so the half will be converted as a product, means R naught will be converted in the R naught by 2 na, the remaining half will be converted as a product. So here K formula we are having 2.303 by, okay, T log R naught by R. R naught means initial concentration, R means final concentration. It is a equation 1, let us say. So now these conditions we will put in first equation. So K is equal to 2.303. Okay, time T is what? Time, that is what? T half. So log initial concentration is R naught. The final concentration is how much? In the R naught by 2. Why? Because in the initial concentration it is becoming half, right? So we will get that time T half is equal to, you will get 2.303 by K log, okay, R naught into 2 by R naught you will get. Okay, if you take the this 7 upside na, denominator will become numerator and numerator will become as a denominator. So R all cancel. So what will get? T of is equal to, you will get 2.303 by K, okay, log 2 you will get, log 2. So from this you will get T half is equal to, you will get 2.303 by K, log 2 means 0.3010. So T half is equal to, you will get 0. If you multiply 2.303 into 0.3010, you will get 0.693 by K you will get. Okay, this is the formula for half-life of a first order. So from this one you can understand that, okay, in zero order T half was directly proportional to A. Here what? T half is okay, independent of initial concentration, independent of A or R naught, initial concentration. Okay, you can see in this formula T of is equal to one number is there, 0.693, means it is independent of initial concentration. So for first order, this graph is very important. For first order, okay, T half versus A graph, A or initial concentration. Okay, so how you will get here T half? If you take on y-axis, it is y-axis and it is x-axis. On x-axis, if you take a, okay, initial concentration A or R naught, if you take, what will happen? T half is independent. Okay, you will get a straight line. You will get. Okay, this graph is very, very important, right? And next, okay, we will understand this half-life concept in common terms. Okay, note. So I will compare the T half of a zero order with first order. Okay, listen carefully. So first we will see zero order. Zero order. In zero order, what happens? 100 molar of a one reactant if you take na, within 1 T half it became to what? 50 molar. In another T half what happens? It becomes to 0 molar, right? So what we have written here, time taken for 100% is equal to, we have written as a 2 into T half. Why? Why? Because the concentration was reduced to 100 to 0. In how many T halves? 1 T half and 2 T halves. Correct? Now, if I want to write time taken for 75% means what we can write? We can write 1.5 into T half. Correct? Okay, the time taken means it will come around here, it will come no, means 75. Okay, 75%. That is T 75% is equal to 1.5 into T half. Now T 25% means what we can write? We can write 0.5 into T half you can write. Okay, these are shortcut formulas. And T 50% nothing but what? It is what? 1 into T half. Okay, sometimes they will give T 50%, they will give, or they may give T half, they may give. Both are same only, these formulas. Okay, means, okay, zero order, okay, 100% will complete it within what? 2 T halves. Okay, now we will see first order. While you learn like this as a differences na, you can compare and you can study na, you can remember easily. Okay, it is first order T half, zero order we have zero order T half, and here first order T half we will see. So this also I am starting with 100 molar. Why? Because it will be convenient to you to understand easily. 100 molar if you take, within 1 T half what will happen? It will become a 50 molar. In another T half what will happen? Okay, it will become a 25 molar, not 0. 0 will become in zero order. Okay, within 2 T half total reaction will complete. Okay, so here what we can write? The time taken for T 50% is equal to, we can write what? T 50% is equal to, we can write 1 T half we can write. The time taken to reduce its initial concentration into 75% na, T 75% is equal to what we can write? We can write 2 T half we can write now. You can observe it is a 1 T half and it is another T half. The initial concentration 100 to became 25. 25 was remained final concentration, means how much consumed? 75%. So the time taken to reduce its initial concentration into 75%, okay, into 25, that is called as what? T75. Now this 25 again in another T of what will happen? It will become 12.5 molar it will become. So now this is the time taken for how much? Time taken for okay, 87.5%. Now time taken for 87.5 percentage is equal to what we can write? We can write 3t of y can write. Okay, you can see 1t of, okay, 1t of, and it is 2t of, and it is what? 3t of. And now if you go for another t of, now what will happen? It will become 6.25 molar it will become. So from here to here the time taken is how much ma? Okay, you can write for time taken for 90, okay, time taken for 93.75 percentage. Okay, 93.75 percentage. So what we can write for 93.75 percentage? Time taken for 93.75 percentage is equal to, okay, you can write 4 into t of, you can write. Okay, like this. These are the formulas. Okay, shortcut formulas. T half is equal to what? 1 into t of T2, T75% is equal to 2 into t of T87.5% is equal to 3t of T 93.75% is equal to 4t of. Now, see, okay, T 100% is equal to how much in first order? Na, it is infinity. Ma. T 100% never going to complete. This is point is very, very important. Infinity. T 100% time the 100% of first order reaction never going to complete. But in zero order, T 100% is equal to how much? 2t of. And one more shortcut formulas are there. That is T 90% is equal to, where it will fall ma T 90% once you see, it will fall T 90 around here, right? Means 3.33 like that it will come. Okay, so it will come like 3.33 into T half. Now T 99% is equal to, we can write another shortcut, 6.66 into T half. Now T 99.9% is equal to, you can write 9.99 into T half, you can write. Or you can write for T 99.9%, T 99.9% is equal to, you can write 10 into T half, you can write. Okay, these formulas you can use for shortcut. Okay, easily you will get. And remember, okay, they may ask T 90% okay is to T 99% okay ratio, and T 99.9% ratio will be how much now? 1:2:3 ma. Okay, 1:2:3 will be. Okay, this one. Okay, this one you have to remember. Okay, this is about zero order as well as what first order. Okay, T halves we have compared. Okay, once again you can see. So we will see some questions related to this one. Okay, so we will see some questions.